Welcome to the session on creating custom integrations. If you're watching this session, you may be wondering, well, what do you mean by custom integrations? And we're going to get to that. First off, I want to start out by talking about our integrations. As you know, Okta has an integration network of over 6,500 different applications. Some of these are SSO integrations using SAML or SWA integrations for that password injection. And the very special ones integrate for lifecycle management functions. Now, if you've attended the LCM 101 sessions here at Octane, then you must be very familiar with the basics of these integrations. The basics being onboarding and offboarding users. For apps like Zendesk or NetSuite, we can create users, read users, update users, and delete users. But as many of you know, that's not really the full extent of your day-to-day tasks, especially when it comes to truly managing user lifecycles. Some of those tasks include changing file or folder ownerships, changing group memberships, or allowing unique SSO flows. So I want to take some time to cover a few of our advanced integration apps. For each of our integrations, our engineering teams spend countless hours writing code that utilizes the APIs of various different vendors. In doing so, we really broaden the possibilities of use cases that you can take advantage of. And in most cases, these are integrations that do more than just basic CRUD operations. The first of these integrations I want to talk to you about is Box. Box is very unique in that setting up users in Box is almost always uses basic CRUD operations. But once a user is created in Box, they need something that's very unique to Box, and that's personal folder. And that folder needs to have a specific name depending on what your company decides. And on the reverse side, that folder also needs to be deleted when that user is removed. So as you can see, this is a very unique use case in that not all apps have a personal folder that needs to be managed. So we added these features to our app integration to make that integration a whole lot more robust. Next up is one that I'm personally close to because of my time as a sysadmin, and that's our integration to Microsoft 365, or it was previously called O365. Just like the Box integration, our Microsoft integration handles the CRUD operations. But in addition to this, there are several different provisioning types depending on your use case. These types can range from basic, simple license management all the way up to a full universal sync. In addition to this, we also support deep provisioning, which also presents its own set of use cases, or unique use cases, I should say. Because in the Active Directory world, when you would disable a user, you'd usually disable them and put them in a special OU. And that same thing is true in the Azure AD world, which is what's actually powering the user store for Microsoft 365. So we built an app with special capabilities that vary how you want to deactivate a user. You can simply block their sign-in or block their sign-in with a grace period. In addition to this, when an O365 tenant is federated with an IDP, such as Okta, all the authentications are routed to that IDP. So for the O365 app, there has to be some very unique and advanced integrations to make SSO work a whole lot smoother. That, in addition to a Microsoft-specific sign-in policy, all encompasses that special app that we've created. And finally, one of our most used applications in the Okta integration network, and that's AWS. Early last year, in collaboration with AWS, we released a new AWS SSO integration. This integration works with AWS SSO, which lets you consolidate all of your AWS accounts into a single interface. Our integration to AWS SSO allows you to manage users and roles, which really simplifies the management of AWS because with Okta, this can all be automated with group roles, which makes the rollout very, very simple. These integrations are great, and for years, many of our customers have utilized these apps and created their own use of these apps as our engineering team has continued to add new features. But let's think about the scalability of that solution. Today, we have over 9,000 customers, and there's one team dedicated to building app integrations. And for those of you in the audience, if you had 9,000 end users, employees, or customers, and many of you do, can you tell me how much time you spend building custom solutions for each and every person in your Active Directory or in your cloud? The answer is probably very little. Now, for those of us in IT, we all follow that old adage of work smarter, not harder. At least that's what I was taught. So what if your app is not in the Okta integration network? Well, as you know, this is actually very common because while the cloud space is growing, many organizations are still using on-prem apps or private cloud apps. And for these apps, there's nearly no way for us to know about them, much less build an integration to them. But we can build ways for you to integrate with them. The first way is by using an on-premise provisioning connector. We call it OPP for short. OPP uses SCIM version 1.1 and communicates with an on-prem web app. Now, if you're new to SCIM, think of SCIM as a standard for exchanging identity information across domains. It uses REST and JSON to automate user lifecycle operations. So, OPP uses SCIM to interact with your existing system. And if you're thinking about it, the answer is yeah, this is a custom integration. And yeah, it's going to take some configuration, but it certainly is possible. And today we have several different partners who actually specialize in this type of custom integration. The end result is it's really an on-prem management from the cloud. So managing things like SAP or JD Edwards, which is pretty cool. I mean, if you've ever had to create a user on an AS400, that's pretty cool. And the OPP connector can also be used with CSV files as a user source, which comes in very, very handy for those HR systems that don't really integrate with anything today, but they can output a CSV file. Now let's get into those private cloud apps. So OPP uses SCIM 1.1 and your web interface to work with your app. And now what if you have your own SCIM server already set up for your app? Well, that's a whole lot easier. Today, as part of our SAML application, you can enable SCIM, enter in your SCIM server information, and within a few clicks, you can be up and running with a custom integration to your SCIM server. Take a look at how easy it is to set it up. So we're here creating a regular SAML app using the SAML app integration wizard. We'll go ahead and finish up the wizard, and once completed, go to the General tab of this newly created app and hit Edit. In here, we'll see the option to enable SCIM. We enable that, save, and now there's a provisioning tab for this app. Here we can see the SCIM configuration. We'll drop in our server name as well as our user identifier. And for authentication, we support basic auth as well as HTTP header. We hit save, and that's it. So far we've talked about the advanced apps our teams have built and are building. We've talked about how to integrate with your on-premise systems using the OPP connector, and how easy it is to add a SCIM app to your Okta tenant. And now I want to introduce you to the next steps in the evolution of custom app creation, and that's Okta Workflows. Okta Workflows is our no-code automation tool that's revolutionizing custom app integrations. And we'll touch on that in a bit, but before we take that route, let's talk a bit about lifecycle management using Okta Workflows. Okay, so here's a quick 2-minute rundown of Okta Workflows. Up here we have Okta Workflows, and inside we have connectors. Now these connectors tie out to different applications. So we'll put Box here, M365 here, and AWS down here. Each connector connects to these different applications, and they connect via an API. Now, depending on these vendors, we'll kind of vary the APIs that are available for that connector. But this is very similar to the app integrations that we just went over. But where Okta Workflows differs is that each of these connectors has its own set of cards. And these cards represent the different app functions for these different applications. So you can think like each one obviously does create and delete user, but each one also has its own unique function. So for Box, We'll have some stuff for the personal folder creation and management for O365. Maybe we'll have something for guest users. And for AWS, we'll have something with roles or some type of permissions. So that's really how Okta Workflows works. So the question is, how do I use it? Okay, so let's create a flow here. This is our flow. When you build out a flow, you'll take a card from each application and create a unique flow that's really solving a use case that's really custom to you. And so you can mix and match these however you want. And so if you think about that logic, you can create one flow with various different cards from various different connectors that pulls from various different applications. And if we have a ton of new connectors, the possibilities are really endless, because on top of this, you also have functions that you can do inside of workflows. So you can do your own data manipulation, and you can create other flows and actually link them together. So this flow can call that flow and vice versa. So really, that's the power of Okta Workflows. So now that we're on the same page for Okta Workflows, here are some of the connectors. First up is Box. Now, when we talked about Box earlier, one of the unique actions of the app integration was the ability to manage personal folders. And yeah, that's a card here, but there's also a card to transfer folders between users. Now, if you think about that for a second, I'm sure you'll come to the same conclusion that I came to. And that is, in order to do that, you'll have to look up each user to get their information before you can move files between them. And you're correct. So there's a card for that. It's the Get User card. So here, already in Workflows, we've introduced new functionality just with Box. But what's great about this is you can mix and match the order of these various cards to create a flow that's really unique to your use case. But what if there's not a card for an action that you want to perform? Well, we build all the cards for the most common use cases. But as Box rolls out new features, they also roll out new APIs to execute those features. So there's an additional card, and that's the custom API action card. This card takes the authentication and the authorization information stored in the connector, and it uses it to connect to any API endpoint you specify, a Box API endpoint to be specific. So as new features roll out from Box, you can take immediate action with those features using the custom API action card directly in the Box connector. Now, let's move on to the next connector, and that's the connector for Microsoft 365. The Microsoft 365 or O365 connector works the same as the Box connector in that the connector stores the authentication and the authorization information inside the connector and has a series of cards that perform actions within that application. Of course, there's the standard functions like create user, read user, update user, etc. But just like Box, Microsoft has its own unique use cases. For example, within M365, there's the concept of a guest user. This is a unique user type that uses an invitation to bring users into a tenant. And it also has a bit of a different pricing model than the standard users. And because of this, a lot of our customers have found that guest users come in very handy for M&A scenarios. Now, using Okta Workflows, they're able to build out a flow that creates a regular user in their primary tenant, but it also creates the same user as a guest user in a tenant they may have just acquired. This makes access very, very simple on day one. You can also create groups, read licenses, and if you're wondering, there is a custom API action card for this connector as well. If you're starting to notice a pattern here, you're right. Each connector comes with a custom API action card. We do this because this gives you the ultimate flexibility to connect to any API endpoint to achieve your desired flow. And that ultimately gives you the ability to customize your connectors. In Okta Workflows, there's a few different ways to perform custom actions. Now, we've talked a lot about custom API actions, which is included as part of the connectors, and it uses that stored authorization and authentication information. But there's also specific HTTP functions that allow you to hit any endpoint regardless of the connector. Now, this is really helpful if you have an on-premise system that you wanted to interact with, during your workflow, or if you had a custom cloud app that has exposed APIs. Now, I can go on and on because we have a ton of connectors. We have one for GitHub, DocuSign, Google Workspace, Slack, ServiceNow, the list goes on. But I'm sure you'd get really tired of me talking about all these connectors and the endless possibilities of workflows. So I thought it'd be better and a bit more interesting for you to actually see it. And I'll let my colleague Pragya give you a glimpse of the custom actions directly in Okta Workflows.
Hi everyone. My name is Pragya Seth and I'm an architect with the services team here at Okta. I work very closely with our workflows team and help our customers implement lifecycle management use cases. Today, I'm going to walk you through some examples with workflows that will show you the flexibility offered by the various features. Just like James mentioned, a number of Okta's connectors offer the custom API action that allows you to extend the connector functionality beyond the existing pre-built cards and leverage the APIs in the target application. Let's get started with this example for the Box app. Let us consider this scenario where we are managing user onboarding guides in Box and would like to notify the new hire and track their task progress in Box. If I log into Box as a new hire, my guides will appear in my homepage here. And if I go to the tasks section here, I will be able to see the tasks that are assigned to me, select them, review the different guides, the files that may be assigned to me, and mark these tasks as complete. We can easily automate this flow using Box APIs and custom API actions in Okta. Let's look at how. In my Okta Workflows console, I have set up a workflow that listens into the user creation event and performs certain actions that allow us to set up these tasks in Box. So let's really look at how this flow works. Whenever a user is created in Okta, this flow will trigger to read the user, fetch their details like the first name, last name, and primary email, and use this information to create the display name and set up their Box user. Until this point, I am using the pre-built action cards that are already available using your Okta and Box connectors in the Okta Workflows console. Once I have the user set up, I will perform the next set of steps that will allow me to create a task in Box, assign this task to this user, and also ensure that the files that need to be reviewed are accessible by this user. In my first example, which is setting up a task in Box, I need to be able to provide the file component or the folder component, as the case may be, and an action that needs to be performed. In this case, I'm requesting the user to complete the action. In some cases, you may also want a review setup. When I set up custom API actions in Okta, I can actually go to the API action card, select my pre-connected apps, or from one of the apps that may not already be connected as well. If your app is already connected, it will use your existing connection, but otherwise you will be prompted to set up your connection in this case. From the list of actions, I will select the custom API action here. This uses the pre-existing action connector and allows me to set up a request type. This request type provides the HTTP method that will be used with the specific API. In my case, I want to select a post because I am setting up this task in Box and that requires it to be a post request. I also have this option to be able to choose what kind of inputs are required. It's very much possible to set up the custom API action using queries, but in case of Box, I need to be able to provide a request body, so I will make this selection as well and save my request. So as you can see, this is very simple to set up, and this requires you to only provide a relative URL. This is because your Box domain URL is picked up by the connection that was already set up, and this only appends the URL for the custom API action. Now, since I already have created the custom API action here, I will skip this step and just review what I had set up previously. So in this case, you will see that I have the relative URL, the body that is mapped from the compose card here, and that's pretty much it. A custom API action will be able to return a status code, header, and a body as well. So once my task is created, I want to be able to use this task to assign it to the user. That's the reason why I want to use the response from this previous custom API action to be able to fetch the task ID that's available as part of the response body. I use the object getCard to fetch the task ID and compose another request body using the task ID as well as my new hire's user ID from box. I have another custom API action that refers to the URL of task assignments and establishes the same mapping between the task ID and the user ID here, taking this as an input. The last step in this process is to be sure that the file that I am assigning as a task to the user is accessible by this user. And this is also a very simple step, similar to the previous two steps that we just performed. I can refer to the collaborations API inbox using this relative URL and also provide a request body. And as you can see in this request body, I have provided the file type and the file ID as well to ensure that this is the file that I want to share. Now this task needs to be accessible by my current user. I have provided the login information for this user to identify the user and also the role that would be available for this user on this file. Okta. Now, your user could be coming from any of the sources like your HR system or your AD imports or even your CSV uploads, right? But in my case, I'm just setting this as an example right now. The thing to keep in mind is that irrespective of the source, this would trigger a user created event and hence that would result in your flow being executed as well. So let's say this user. Now that the person has been added, we should see that the task is also executing in the backend. So let's go back and review the flow history here. You can see my user Tony has now been created. I'm fetching the details of Tony, creating the user inbox, and as I move from left to right, you will see the execution of each of these tasks and their details in here as well, along with the custom API action. Now that my flow is complete, let's go back to Box and admin console that my user Tony is now created. So let's log in as this user and see what their experience looks like. So I'm now logged into Box as this new user, and you can see here on the landing page that the file that was shared with the user is now available. And if the user navigates to the task assignment, the tasks are showing up here in this section as well. The user can review the file and then go ahead and mark their task as complete. So with this example, you saw how easy it becomes to set up a new API using the custom API action and be able to extend your identity use case to something that is broader than what is available with the pre-built action cards in the Workflows console. Let's look at another example with Office 365 custom API actions. Your Office 365 environment can have a number of users, and these users can be assigned to different roles. In this example, we're going to review how you can build up reports or even store this information in table where you are tracking which user has access to which role. In my example here, my first user is set up in such a way that they have access to this role, Service Support Admin. And another example of this user has a help desk administrator example. So as the list keeps growing, it becomes more and more difficult to manage this. So what would help my organization is that if I can produce a weekly report of which users have access to which roles, it would really help me track these different user roles as well. So let's look at how to set this up in Okta. So I have set up these flows that allow me to monitor the admin roles in my Office 365 account. And I will be leveraging custom API actions for this purpose. The task of these different flows perform is to look up each of the role mappings and save them in a workflows table. The first task or the flow that I look here is a scheduled flow. So this is the parent flow which triggers every week. And as a first task, it uses the utility flow, which I've created, clear the table, which basically reads all records in the table and deletes them. The actual task of this flow starts with the custom API action. And very similar to how we saw in the box example, I need to provide a relative URL in this example. I'm also using an Office 365 connector that was already established prior to setting up the API action. And once I set up the connector, I just picked the right action card for this custom API action. Once I've picked custom API action, as we saw previously as well, this gives me the option to select the request type that gets tied to my API. In the first example, or the first lookup that I need to do is just pull a list of all directory roles that are available in my Office 365 admin console. So I am placing a GET request on the directory roles URL. Once this card is executed, the body will be able to provide me the list of all admin roles, and I will run a for each card, which would allow me to actually navigate through the list of each and every admin roles and look up the role members. So in this child flow that I have now invoked with the for each card, I'm passing on the role information, and with this role ID that will be fetched from the role information, I will look up the members of this card. Again, you can see here that this custom API action was set up in a very similar format, but the URL here takes the role ID as an input as well. The result of this custom API action will return a body that will be a list of all the members. I take the body object and fetch the member list. And then I use this member list in another child flow using the for each list card, and then perform the action of actually saving this information in my workflows table. Let's quickly go back to my first parent flow here and see how this is being run. So I'll hit test, and that will be a quick execution. As you can see that the first, and as this task runs and is completed, if I go back to my table here, you will see that this is now populated with the new information. While the custom API actions are a great way to extend the pre-built connectors, there are times where you may want to integrate with applications outside the workflow's connector catalog. This is where the HTTP functions come in handy. I'm setting up the Heroku app for my organization, and I would like to automatically manage user deactivations whenever the user is unassigned from the Heroku app. The Heroku app allows me to invite users, and I have already set up a couple of users here. Let's look at the workflow that triggers user deletion once the user is unassigned from their app in Okta. In my Workflows console, the first thing I need to do is set up an HTTP connection. For this, I go to the Connections tab here, select a new connection, and choose my HTTP option. I will provide a name for my connection here. And this connection will establish how my API access will be authenticated against the application. Different apps allow different options to choose the authentication type, and the same way I can set up this option here as well. When I select basic, the API will authenticate using a username and password. If I select OAuth as an option, this will initiate an OAuth connection, and the access token that is fetched will then be used for any further API access. In case of Heroku, I will select a custom option and set up a header for authorization. This header will have a bearer token value using the key that was provided to me by Heroku. Now let's look at the flow here. So I'll go back to my folder and open the flow here. This flow gets triggered whenever the user is unassigned from the app, so I'm listening to that specific event in Okta. As soon as this event occurs, the first thing that I will do is read the user to fetch their username and primary email information. Like you saw in the Heroku app, the primary email is used to identify the member in Heroku. And that's what I will use to actually delete the user up here as well. In my next steps, I am actually constructing my API request. As you will see here, I have an HTTP delete CRUD, which actually carries out the API action. In order to complete this delete request, I need to be able to set up the URL that needs to be provided for this API action, as well as the headers information. I construct this using the text compose CRUD. The API URL, as you will see, is the full URL in this case, which is different from the custom API action URL that we saw earlier, where we needed to provide only the relative URL. Also, in case of the headers, you will see that there is a content type that I have provided here, and an accept header, which includes the Heroku app version. The header requirement can actually be different for each application, and based on your APIs, you may want to provide different header values as well. Lastly, we have the HTTP delete CRUD here. In order to set up this CRUD, you need to go to the actions functions part and select HTTP advanced actions and choose the API action that you need to perform. In my case, I have picked up delete because that's what's required to delete my user from the Heroku app. The HTTP CRUD also allows you to provide a query parameter and a body if that is required by your APIs. So it's very much customizable, and in the query parameter or the body, you can provide either a text or an object type. The HTTP CRUD also sends back a response with a status code, header, and a body information. Now that we have this flow set up, let's look at how to test this out. So in order to run this, I will go to my Okta console, and in my Heroku application, the user that was assigned, I will just unassign this user quickly here. As soon as the user is unassigned, this will trigger my flow. So in my workflow, let's look at the flow history. You will see that my flow has run and it has pulled the user information from Okta and then used this to send over the delete request to Heroku. And we can quickly validate this in Heroku. If I come here and just refresh my screen, you can see that the user does not exist in Heroku anymore. Hope you enjoyed these examples. Have fun building workflows in your environments. Back to you, James.
Thanks, Pragya, for that demo. As you can see, the custom API action cards gives you a ton of flexibility to create a card for nearly any use case. And as you can imagine, building out these custom use cases can take up some time, but they're going to solve so many different problems that are really, really common to the IT community and to other sysadmins just like yourself. Also common to that IT community is really sharing these solutions. So logically, you'd wonder, Okay, well, if I build this solution, how do I share these custom API actions? How can I share these connectors with others? And for that, I'll let Nate share a bit of information with you.
Hi, my name is Nate Callahan and I'm on the product management team here at Okta. Today, I'm going to provide a quick overview of the new Workflows Connector Builder functionality. Connector Builder is a no-code development tool for creating connectors on the Workflows platform. It leverages the same drag and drop workflows functionality used by current Okta Workflows customers to turn their use cases into automated flows. For the beta period, the team is targeting the feature set necessary to create custom API action cards. CAPIAs allow Workflows end users to make authenticated HTTP requests to a single service and avoids much of the hassle of using the HTTP functions by coding the base URL into the connector and managing the authentication. In this short example, we're using a CAPIA card to make a call to Okta syslog in order to retrieve a list of syslog messages. Then we're filtering down the response to a list of messages for only a single user. When testing this flow, we provide the relative URL for the syslog endpoint and the name of the user whose messages we want to review. And in our flow history, we can see that the call was made successfully and that the messages were filtered properly to only those for the indicated user. So how then do we make a connector? At its most basic, a connector is a collection of API endpoints and data manipulation functions sequenced into flows. Connector Builder packages these flows along with authentication and branding so it can be used by all Okta customers on the Workflows platform. Customers can also build connectors for their own internal use without sharing them with all Okta Workflows users. Connector Builder users can manage the basics of their connector's branding on the settings page, where they'll be able to add a name and description as well as specify a color and logo. Authentication is where users will define the parameters that are needed to create a connection to a third-party service. Basic authentication for APIs that only require a username and password, OAuth 2.0 authorization code, and custom authentication used for collecting any value like an API key will be supported during the beta. Flows are used to create the various functionality that makes up a connector and consist of HTTP requests and data manipulation functions. In the example displayed here, you'll see three flows: a system flow we call authping that helps determine the health of a connector, a custom API action flow that represents the action method displayed to the end user, and an HTTP helper flow that manages both the authentication for the connector as well as the HTTP request itself and any necessary error handling. The I/O modal is where users will define the inputs and outputs of their connector cards. Any number of inputs or outputs can be added to a connector, and the platform even supports the creation of drop-downs, as seen here when defining a list of HTTP request types. Once added, the new values can be easily used within the connector flows by dragging the fields from the event card. Once the flows are completed, the connector can be deployed for testing within the Workflows product. The Deployment tab is where builders can publish different versions of their connector to their associated Workflows tenant to test complete use cases or for their use in production flows. Users will be able to publish both test and production versions of their connector to their own Workflows instance, as well as submit their connector to the product team for potential inclusion in the catalog. Please note that during beta and early access, there will be no SLA for deployment and all submissions will be handled on a best faith effort.
So as you can see, the progression of Okta Lifecycle Management started with our OAN apps, moved on to OPP as a connector, then to the SCIM app wizard, then into Okta Workflows. Now the custom API action functionality in Okta Workflows allows you to connect to any API endpoint for any given connector. And HTTP functions allow you to connect to any API point, and soon the connector builder will allow you to share these custom connections and cards. Now, here at Octane, we have a ton of sessions on Okta Workflows. So if you'd like to learn more, feel free to browse through the sessions and jump into any of the other Okta Workflow sessions. Thank you.